12-factor apps. Bad for smaller dev teams and people who hate bugs. Okay. Hello, I'm Chris Thess. I'm a KMP developer. Tech Support said they're coming out to fix that as soon as possible. They said Tuesday, but they say that a lot. Today I'm going to be reacting to Internet of Bugs, which I've been following on his artificial intelligence stuff. And now I want to see what he's saying about this 12-factor thing, which I looked it up, and it is something from GitHub, I guess, where you have these different things that how you set up and build your applications, which seem to be very much like CRUD enterprise oriented, and definitely web based. So it's not all apps. It's just there's certain category of apps that need to be scaled and have admins, and I mean this is a lot of apps that do that, but it's all like CRUD stuff. So this isn't. There should be like CRUD web apps 12 factors. Let's see what the master has to say.
Last week, I talked about rethinking what you build and what you don't build. I gave the example of a new trend in sites that refuse to store users' passwords at all and to only allow logins via magic links.
I mean, I did an app with that. It worked out great. Nobody could possibly hack into our account unless they get into your email. And if they get into your email, well, I mean, kind of all bets are off at there, right? Yeah, so I do like that idea. And I also like the idea of, especially if you're small and don't want to mess with this, to offload their password management to somebody else, something else, OAuth, etc.
I'm not saying you have to do that. It's just one example of how the way you might be used to doing things might not be the best in a project designed to be hands-off as possible.
Correct.
So today I'm going to go deeper.
I agree so far.
To give me a framework for this discussion, I've chosen to talk about a set of practices called the 12-factor app, which you can find at the address right here if you want to look at it yourself. Now, before I start trashing this thing, I want to emphasize that you could do a lot worse as a starting point than these 12 factors.
I mean,
web apps that are built with these principles are definitely better than a lot that I've seen in the wild, and it's good to have some structure, especially when you're a beginner. And I applaud what the folks behind the site were trying to do.
Yeah.
But it's inevitable that anyone who tries to boil down all of software development to 12 bullet points is going to...
Yeah, I mean, when I looked it over briefly, it's not all software development. Let's keep going.
...have to drastically simplify, make a lot of assumptions, gloss over potential exceptions, and unavoidably omit things. And 12-factor isn't as limiting as, say, Git Flow. And as far as I'm concerned, it has certainly done much less damage to the industry.
I remember the Git Flow thing through. It's just like which branches you purchase your stuff into, and it's, man, they overcomplicated the heck out of it. Like they took an okay idea and they just went way too crazy with it. Let's keep going.
And Agile or Scrum or Leak code interviews or God.
Yeah, that's solid. He hates solid as much as I do. I've been digging on Uncle Bob the last few videos of it, just dogging him out with his. We never really got into his solid stuff a little bit, but yeah, it's goofy.
Forbid the solid acronym. That stuff is just...
I'm glad he agrees with me. I mean, it's useful things to think about, but it's not like these are the commandments. These are Uncle Bob's commandments of software development. If you're not doing these, you're not doing software, buddy.
This is Internet of Bugs. My name is Carl. I've been a software professional for more than 35 years now, and I'm trying to do my part to reduce the number of bugs on the internet.
Okay.
So let me set the stage here and talk about general trends in software development before I talk about the 12-factor app framework specifically.
Cool.
As software has become more complex and its practitioners have become more specialized, there are certain patterns that people have fallen into, and this 12-factor app is indicative of some of them. Specifically, there's a tendency to adopt practices that make it simpler and faster to build software that works under most circumstances, at the expense of being able to troubleshoot and debug those circumstances when the software doesn't work right.
Okay,
those practices put abstraction layers, obfuscation layers, really, between the architecture of the high-level code and what the code actually does.
Yeah. I mean, that's the whole thing we're doing the whole time. But yeah, sometimes they fit and sometimes they don't fit.
Those practices, like the 12-factor app and many others, enable software that is of lower quality and harder to troubleshoot to get put into production a lot faster than it would have been otherwise.
Possibly.
That sounds familiar. Something that writes software really fast, but that causes the software to be buggier and harder to understand. Now, where have I heard that before?
Anyway. He feels like I do, yeah. I mean, he kind of feels like I do. It's like the stuff is useful, but if it's not going to replace our skill sets, our skill sets are going to have to be a little different than they were when you had to memorize code snippets.
I need to establish one more thing before we go forward. In this video and in past videos, I talk a lot about practices that make things easier to program, but make things harder to debug. That's pretty abstract, and I want you to get a feel for what I'm talking about. So let me give you a concrete example. Let me tell you a story about the time I broke Amazon. Well, not all of Amazon, just Amazon's ability to balance their books so they could publish their quarterly reports.
All right.
Not that that's important.
All right.
So some details have been changed and simplified to avoid giving away any secrets and to make the story take a little less time to tell, but this is more or less what happened. So I was working in Amazon Logistics, building the offering used by the Amazon delivery drivers that drop off the packages on your porch and take a picture of it.
Speed this up a little.
So I was working on the fulfillment side of Amazon, and somewhere else in Amazon, probably in Seattle, was a system that did the ordering side of Amazon.
Oh, so you guys really didn't have like a don't talk to each other. Don't get, God forbid you talk to each other.
And of course, since the ordering side and the delivery side were dealing with the same order numbers and the same products and the same addresses and the same customers, et cetera,
Okay.
those systems had to talk to each other somehow, and that somehow was with a message queue. Now, as I've talked about before, I was testing our system myself by buying things with my own money that needed to be delivered to me, and then going to the fulfillment center, signing in to be the delivery driver, and then delivering my own packages on my delivery driver account so that I was both the delivery person and the recipient at the same time on 2 different accounts on 2 different sides of Amazon.
Not unusual.
So early on in our test phase, sometimes.
Ridiculous, but not unusual.
For some reason, after I delivered a package, the app I used on the ordering side of the transaction would lock up. Now, this has all been merged into the main Amazon mobile app now, but at the time, same-day purchases were done in a separate app that was called Prime Now. So what was happening was that when the "it has been delivered" message was sent on my side, it was sometimes being rejected by the order side of the house, and then that was causing the Prime Now app to freak out. And that order just
freak out? I mean, fail? Okay.
Was frozen in the system and couldn't be closed. Not always, though, just sometimes. And I was completely at a loss as to what the hell could be going wrong. So I'm trying to figure out what's going on. Turns out
these are the best bugs, by the way. They'll drive you slowly insane. A lot of people quit because of these bugs.
Folks on the order side were also trying to figure out who was sending these bad orders, and it took far too long for me to end up in communication with them.
Well, isn't that a little bit of friction going on? Let's keep going.
And then we had to figure out what was going on, and finally we figured it out. And I'll save you the comedy of errors of all that, but it turns out that the message being exchanged via
normal stuff. It's not. This is normal. This is the job. Most of the time is this junk. No, how am I gonna code doing it? It's like, no, we kind of fix that problem mostly, like what the snippets are for your thingy, but like all this other stuff, how are you gonna get the AI to do that? Good luck.
Via the message queue had a string field that was basically a delivery ID field, and that field was generated on my side, and it got saved in their database as a foreign key to be used for reconciliation later. The string I was using was a composite value. I was using an algorithm, and I was combining the item ID and the driver ID and the date, some other info, so that given a delivery ID, I could decompose it and figure out what that ID represented.
There's his first mistake, but I know what he's doing, and I've done things similar, but having some standard ID mechanism, which can obfuscates the ordered ID. I don't know if that's going to be good, man.
For troubleshooting purposes. But that made that string of variable length. And it turned out that the Swagger specification document on my side of the transaction for that field had a maximum length value that was a bit larger than the maximum length value of that field in their system. Yeah. And so if that string happened to get built of values that caused the ID to be at the maximum of what my Swagger document said was okay, it would get rejected on their side because it was too long.
So even with a shared document API documentation, this stuff still comes through. There's no way to nail it down unless you're all using some similar system that's all has shared idioms.
Long.
Good luck with that.
But if it wasn't too long,
KMP gets close. By the way, I'm so excited about KMP. KMP gets damn close because you have one language, front and back, etc. I've already gone over another movie.
It was a different set of orders that just happened to create a smaller, shorter string. Then it worked just fine. But before we figured out that information, it was virtually impossible for me, when I'm looking at my database records of orders, what was accepted and what was rejected, trying to figure out what's going on. I had no idea what was going on.
It's unnerving. That would be unnerving when you think you don't have a problem with your, it's just an ID. It's just an ID. It's not going to fail. I guess just everything has an ID, right? He's looking at every single thing. Oh man, what a nightmare.
And it was definitely possible for them to tell on their side because all the information relevant to understanding the problem at all was being hidden by the abstraction that was this message queue. So we got that figured out eventually, and I just ended up creating a UUID to put in that field. And
as well, you should have in the beginning, and
then just made a lookup table to get from that UUID.
That's what you should have done in the beginning, but keep going.
UUID to the other order details that I wanted. And all was well until the end of the quarter when one of those frozen unreconciled orders happened to have a gratuity amount attached to it that had been pulled from my credit card as a customer as part of the order, but that amount had not been paid to me as the delivery person. And so there was a mad scramble to get that amount to be balanced so that the accounting software could be happy and they could figure out the quarterly report. Fun times. Anyway, that message queue was one of those techniques I'm talking about. It made it possible for Amazon to get that system into production without having to go through all the time-consuming processes of getting my team to interface directly with their team and all the other teams whose stuff we talked to, and it saved a bunch of time on all the different sides until something didn't work, at which point it would have been so much easier to debug if there had just been a direct connection. If my code had directly received an error from their SQL database that said maximum length exceeded for field delivery ID.
This is one of the problems with decoupling everything, is you don't have this granularity at the errors. It's just error comes back, error. failed. Like, what failed? Well, that's not part of the API, so all you get is a failure.
The first time something went wrong, it would have taken me 5 minutes to fix the whole thing, and we could have avoided the whole nightmare. For a project the size of this at Amazon and a company the size of Amazon, a message queue is exactly the correct kind of architecture.
True.
Because there were so many teams involved and the system is so complicated, the queue actually made things simpler. And even with the problems that popped up, it ended up, I'm sure, saving time.
Yes.
However, if you're a small team, or really if you're a solo team, building a software as a service project, then that trade-off is very different.
True, I agree.
Which means that if you...
That's why I get into the MVP, the first thing you build. Don't worry about this message queue. Just access the stuff directly. Yes, you're going to boundary on the number of users and simultaneously and all that stuff, but just getting something that gets a product market fit where you have a customer that you've identified in a problem in a solution space that you can put together rapidly to see if you actually have a customer base that you can move forward with. So yeah, you should not use the message queue at first. You should just directly wire it up. Now, when you get customers after your 500th customer or whatever, it's like, we should really, we're going to have an upper boundary of like 5,000 customers on this system. We're not going to be able to go past it without people complaining. Okay, well, it's trying to go to a message queue. Well, then you'll know, just take that system and then implement it with the message queue, not add a bunch of features in the meantime. Like, that's not, we can do that later.
If you use that technique to get to market faster, when, not if, but when something goes wrong, one of two things is going to happen. Either you're going to spend more time troubleshooting the problem than you save taking the shortcut in the first place.
Right, because you're going to be messing with the message queue and the database and your front end, as opposed to just your front end and the database. There's another thing in the middle. That's non-trivial thing to deal with, especially when you're trying to get a custom product market fit.
Or you'll do what most of the internet does, which is shrugging your shoulders, closing the ticket as cannot reproduce, and hope it doesn't happen very often. Now, given that I am someone who professionally complains about the internet having too many bugs already, you can tell where my preference would be. Great. Now it's 8.5 minutes in, and it's time to start the actual subject of the video.
Fair.
So, I'm not going to go into detail for each of the 12 points. Instead, I'm going to talk about the limitations that these ideas cause and how those limitations relate to the different points. So starting off, we're going to talk about items 1 and 3, one code-based track and revision control, and store config in the environment.
Okay.
So here's the information.
Those are good things for web apps. Yes, you should have a source control because you might have to dial it back, if you have a bug or if you've got multiple people on a team. Yeah, and then what do you say, the config? I mean, having a config in a file is way better than having it in the source code. Let's keep going.
Information losing abstraction in that case. In order to debug problems, you often need to recreate a version of your application as it existed at some point in the past. Yeah. How does this help? Because once you can reliably reproduce a problem, one of the fastest ways to fix the problem is to answer the question, when did this bug appear and what code changed between the commit before the bug existed and the commit after it did? This is what git bisect is for.
Yeah.
The resolution process, if that feature never was implemented correctly in the first place, is very different than when you find out that it was somehow caused by this specific 3-line code change that happened last month. Right. If you have a single code base that contains everything and a .env file that's not under version control, and you want to run your software as it was a month ago, but in between that time, you've made a bunch of changes to your architecture or your operations environment, like say you chose hosting providers from AWS to Google Cloud or something, and you're trying to figure out if the bug was introduced as part of the vendor change or if it was broken before the switch, how would you do that? You need to deploy your old code to the new cloud or reinstate your old cloud. But when you check out your code base from back then to deploy a test build, all the test scripts and build scripts and deployment processes, et cetera, are all pointing at the old cloud. Or those scripts don't exist anymore at all because you never checked them in. Now that seems drastic. How often do you change cloud providers? But I'm just using that as an example to make it easier for you to understand. Trust me when I say that build processes
There's all kinds of little things like
all the time. And even little changes that don't seem to be a big deal can add up to an incredibly time-consuming process when you're trying to deploy.
Hello, Android.
An old build.
So I don't know. React also has this issue. Angular has this issue. All of these flat frameworks, you don't fully kind of think things through. They're just kind of winging it. But saying we got the ultimate now and no more problems now. We're smooth sailing, except a year later, like, we came out with a whole new thing. How to do it. Let's keep going.
So here's what years of bitter experience has taught me is the best practice. You need 3 pieces. First, you need the code base with your application code in it. That's more or less like what the 12-factor app is talking about.
Okay.
Then you want a completely different repository that contains all of your scripts and automation for all of your builds, deployments, continuous integration, environments, all that kind of stuff. That's all checked into source control so you can track it over time.
I mean, why do they have to be separate? I don't understand why they got to be separate, but let's keep going.
So if you want to deploy your code from a month ago to the new Kubernetes cluster you just built last week, you can. It might take some tweaks to get everything running, but you've got ready.
I guess this might be some way enterprises can handle it. They have all the config scripts in one repo and the app in another repo. Okay.
Access to all the information between the new deployment repo and the old code repo. I could go into a lot more detail about how this works, and I will probably make a whole video about that at some point, but
That'd be
hopefully you at
useful.
least understand the concept of what I'm describing.
This is the kind of stuff I expect Uncle Bob to be talking about. You can tell this guy's down the pit, and he's been in the pit lately, and he's still in the pit, and he's like, we're lucky enough to hear what he has to say and still being in the pit, because most people give up by the time he gets this guy's age. He's like, screw all this shit. So yeah, but this is Uncle Bob. I figured Uncle Bob would be talking about this kind of stuff, but he doesn't. He's just, I'm gonna make a blurb and an acronym, and I'm gonna talk to the troops about making the code clean. I'm gonna make the code good, whatever that means.
Right. But remember I said you needed 3 things? The third thing you need is some encrypted thing that you use to keep all of your secrets and passwords inside.
Okay, yeah. With Android, we've always had you've had to keep your secrets in some other password manager or whatever, and your source code in separate. So yeah, that's kind of industry standard, at least for Android, and maybe other applications, other providers too. You don't want to keep your passwords out of your repo. Come on.
Most cloud providers have their own service for this. AWS Secrets Manager, Google Cloud Secret Manager,
that's cool.
Or there are a number of other choices, third-party software, self-hosted open source stuff, a managed service, whatever. That stupid env file contains all of the passwords needed to connect to all of your databases, and that is one of the most common vulnerabilities by which customer information gets stolen.
Okay.
So here's a story about a botnet that just crawls the internet looking for unsecured env files.
I mean, I thought that was a thing people are checking for already with all the services that are built in. But I guess not. Let's keep going.
And here's an article for 6 months ago about 110,000 domains that were exploited because of
I mean, it's very common to make mistakes on these things. I mean, the internet was not meant for security, so yeah, this is expected.
env files. You don't want to end up in that situation. Multiple times over the years, I've been working on networks.
Not to be, it's so difficult. You gotta be super careful, and even then, it's just try to mitigate it somehow. I don't know. It's like such a big problem.
Been the one that discovered the hack while it was in progress. And then I've had to clean up after the networks were compromised. And that's not fun at all. Not to mention having to talk to customers about the information that was stolen. I'm sure I'll get to tell some of those stories at some.
By this time, everyone should know all your information is all available on the internet for very low cost, if not free. So just know that that's the thing. If you haven't secured your bank accounts yet and put freezes on your credit card or your credit reports, you should do that.
So if you possibly can, avoid anything that is commonly used by the bad guys to hack systems. And the good news is, if you're building a system and you're your own boss, then you can choose what you do and don't use. It's often not the case when someone else is making the decisions.
True.
And this idea of a secret service brings up another issue, namely the idea that the 12-factor app environment is intended to be explicitly agnostic to the environment that it's run in. There's not a specific bullet point for this, but it's inherent in a couple of statements, like do not rely on the implicit existence of any system tools like ImageMagick or curl, which is in point 2. Dependencies, or the 12-factor app is completely self-contained, which is in point 7, which is on port binding. This agnosticism of which cloud you're on or whatever is entangled with a thing called Conway's Law.
Right.
I talk about that a lot. It's about the inevitable similarities.
Yeah, Conway's Law, we're never going to get away from it. You cannot get away from this. I know as a developer, like, well, it should be pretty easy just to go ahead and just implement this. Like, no, because you're going to be dealing with these departments, and they all have a staffing, and they have little fiefdoms, and it's just corporate structures that going back to like the 1600s that we haven't gotten away from. And maybe also they might be just how humans are just kind of inherently do things. They want to be like this hierarchical structure, maybe just what our species is into. Yeah, we're not going to get away from Conway's Law ever.
The organization of the software design and the organization of the people in the company that produce and run the software. In a big company, the ideal situation is that the operations team that keeps things running ought to be able to move an application from one cloud vendor to another without having to get the development team involved at all, because no code changes would be required.
That's the dream.
But again, that layer of abstraction that isolates the application from what cloud it's in, it comes at a cost. It can lead to stupid lowest denominator practices like storing passwords in plaintext.env files, instead of being able to use vendor-specific services that allow things to actually be secure.
Well, that takes training, it takes time. We got to put tickets on that. Are we gonna put time on that? That's time training, and everyone has to get it right. Is there testing environments? How do you test that stuff? How do you make sure it's right? You're asking a lot. It's not like just putting it as a password manager. It's like, no, there's more to it than that. If you're gonna automate this across an enterprise, holy shit, man.
And it also leads to a bunch of information hiding stuff that makes debugging harder, kind of similar to the way that the message queue obscured the specific SQL error message that I needed from getting back to the developer to cause a problem.
Right, that wasn't in the API. You weren't expected to have an error. And if there was an error, you're not expected to know what it is.
Amazon story. And that leads into the next issue I have with 12 factor, which is that it assumes an inherent isolation and separation between the development team and the production server environment. In other words, the people that operate the production servers are different people than the people that wrote the application that runs on those servers. Again, this is
So
what protects against
assumes enterprise.
insider theft in a huge company.
Even then, it's like, oh man.
But it allows bugs to be incredibly difficult, if not impractical, to solve. And that disconnect is also.
By the way, this is a big opportunity. This doesn't have to be this way. This is just the way it's been done. It doesn't have to be like how it is. This is why there's an opportunity right now using these AI tools for smaller teams to take over some of these companies because they're stuck. They're stuck, I tell you.
It's an opportunity for security issues to be exploited, again, like those dummy NV files. Can you tell I don't like those? So this is another one where there isn't a specific point in the 12 factor bullet points. It's a thread that kind of runs through several of them, like it's impossible to make changes to the code at runtime since there's no way to propagate those changes back to the build stage, which is in bullet 5, build, release, and run. Or expecting future requests from the same visitor to be routed to the same process, which is called sticky sessions. That's a violation of 12 factor and should never be used or relied upon, according to bullet 6, which is called processes.
Huh. Okay, I don't know if I agree with that.
There have been many bugs in my career that have been most judiciously resolved when I personally log directly into the production runtime servers to look at things and occasionally even make changes. So I have made code changes directly to a backend server at 3 o'clock in the morning because a particular transaction request that kept coming in was causing the service to crash. And it needed to get fixed quickly before we violated our service level agreements and had to pay huge fines. So I just coded directly onto that server and put it.
Right, but I guess the point is those heroic level efforts are not scalable, are not sustainable, and are not replicatable, and you can't rely on it for the SLAs. So either SLA has to change, or the work process has to change, or something has to get up the chain that says that a heroic effort was involved in making this happen, and there should be some changes to the process that don't require heroic level effort at 3 o'clock in the morning to maintain a service level agreement. I mean, I appreciate it. I've done similar things. I get it, but like from adult eyes, if your business is relying on people to do hacks at 3 a.m. to keep your business running, you've got some other problems.
Put it into production. I have intentionally crashed.
As a normal basis, as a normal thing. I mean, we're once in a while. It's fine every once in a while. It's a random exception. But as a normal rule, let's see, your business is about to be taken over.
One of the web servers in a big production cluster so that I could dump the application's memory and go through it in a debugger in order to diagnose a performance problem.
Old school.
It turned out that a change that we had made to make heavier use of the link lambda functions was causing the C# just-in-time compiler that was building the lambdas and the C# garbage collector that was cleaning the lambdas up were combined, taking up the vast majority of the CPU time on the whole server, leaving no time for the server to actually, run the stupid application code it was supposed
to. the startup and the shutdown code were taking much longer than the process, so it never just able to complete. All right.
So you're running. That one was a nightmare because
that's some goofy stuff right there. That's you're relying on stuff that wasn't like completely tested for that particular situation. I know it's like you talk to Link guys like, well, you shouldn't have been doing the XYZ with the ZYM. It's like, is that in the manual anywhere? No. Is that documented anywhere? No. Is that in any support or any of the classes or anything? No. But you should have known anyway. It's like, are you guys crazy? This is why he's bald. He lost his hair doing that stuff.
Only appeared when the box was under heavy load, and we were never able to reproduce the problem in the lab, even after we knew what the problem was. I've also made a special server build.
So bullshit. Like there's like stuff that's like that. Oh man, you just have a couple of bugs in your life. You're like, is this really the right job? Is this really the right field I'm going into? And it's somebody else's code. You don't know what they're trying to do. You don't. They're not around anymore. They got laid off 2 weeks ago. 2 weeks ago because they got a bigger $5,000 offer from another company right across the street, and they got better parking and better facilities, and they're moving up into management. And so it's like a lot of that stuff. It's like, holy shit. So a lot of stuff, these missions aren't because you want to do it for the company. It becomes sort of like this son of a bitch problem. I'm going to understand how this thing's put together. But at the end of this thing, I am going to know more than anybody else knows about this. It has to be that kind of mission. Like, it's just personal. It's got to be kind of like that to keep doing that stuff. Because that's like, if you're, okay, you did that last weekend. Okay, you're going to do a week this weekend. And this weekend again, this weekend again. It's like, no, that's not how this works.
in a different project would have had so much extra logging that the server ran several hundred times slower than normal.
Logging doesn't cause any performance issues. We can log as much as we want. Gigabytes and gigabytes. Well, our application is logging. That's what it all does is log.
I configured the front-end load balancer to route to that server, that part of the cluster, only for the sessions that met a specific set of criteria that we had identified as being involved in a bug we couldn't figure out.
What a nightmare.
And the next time a session came along that triggered...
See, all this stuff, all the software's been written in this way that's not monitorable. We don't know how to debug it. We don't know where it's failing. We don't know why it's failing. We don't even know where it's failing. We don't even know what's causing it to fail. All these applications were written, they're like, oh no, it's not never going to fail. We're running this in sprints. Don't you understand? This is a solid application. Uncle Bob Tank, he said all you gotta do is use solid and we're good. He's like, yeah, solid might not be all you need.
The bug happened on that specific logging build. We got an impractically huge amount of extra local log files that we couldn't have been able to support on the whole cluster. And then I dissected those log files over the course of several days to figure out and fix what was actually going on. For the record,
I've done things like that. I'm getting flashbacks right now. If you're on a schedule or some sort of deadline, this is just nightmare mode. This is stuff that haunts your dreams. Wake up with a bit like, logs.
That is also disallowed under item 11, logs, of the 12-factor app.
What?
I have no idea how I would have successfully resolved any of those three issues under the...
Maybe he's just being pedantic, but no, this is how everybody does it. Unless there's some new... See, what we need is some tools into the operating system that gives us peepers on this. That's like designed to deal with these types of nightmare scenario bugs, which happen all too often. It's just that the OS was not designed to be able to have a view on these things. Because if it did, it wouldn't take in days for them to go and look at this stuff. We just don't have the tooling yet. And when people are like, what do you mean? What do you mean? AI is going to solve all the problems. It's like, how about solve some of these problems?
Constraints and requirements of the 12-factor app. But if I had, I know it would have taken much, much longer. And more likely, management would have just decided to ignore or try to avoid the problem, like all those companies who had their customer data stolen because of their use of .env files. So at this point, I've touched on 7 of the 12 factors in the 12-factor app, and hopefully it's given you enough to think about for a while. I have a few other less fundamental gripes with 12-factor, but instead of making this video even longer, now that I've gotten the really important ones out of the way, I'm just going to put those in my next supplemental newsletter issue, along with any current events that I think shed important new light on things that I've said in previous videos. You can sign up for that using the link right here on your screen or down in the description.
All right, that's cool.
So I hope this has been useful to you, and it's helped you see how software principles that seem perfectly reasonable when you're thinking only as an application developer can have huge consequences that can lead to more internet bugs. And I hope we can all agree that we don't need any more internet bugs. Because the internet is full of these kinds of bugs, and a lot of them are caused by people who are trying to sell you something that they say will make your development go faster, while downplaying or just ignoring the trade-offs you would be making by using their product.
Yeah, everyone's drowning in these issues, and it's just all the hucksters know that. They're like, because they get done the sales calls and the objections. Well, can you fix this? Can you fix this? And like, maybe we should do something to fix that. So yeah, but they're not doing these deeper ones, which are really hard to fix, honestly.
Excuse me. So until next time, thanks for watching. Let's be careful out there.
All right. Yeah. Okay. Give me a like and subscribe. Whoa. Give me a like and subscribe, and I'll try to control my computer. And I will talk to you soon. Give me comments in the thing below about whether if you checked this thing out, this 12-factor or not. I don't know. It's kind of goofy. I like Cupid.